It works on my machine. Have you ever heard or said this? Or it works on Windows but not macOS? Or have you ever struggled with juggling different Node.js versions for different projects? This is why Docker was created in 2013. And it's not just a tool to solve compatibility issues. It's a critical skill required for the highest paying jobs, as surveys find Docker to be the most popular tool used by 57% of professional developers. If you don't learn it now, you significantly lower your chances of landing a job. So welcome to the most modern Docker course. This isn't an outdated high school group presentation style course. This will be a detailed but easy to follow course in which you'll learn a key technology professional developers use every day. I'll teach you what Docker is, why, when, and how you should use it to Dockerize modern web applications, how to make your life easier by using Docker Desktop, how to master Docker fundamentals to use other people's Docker images and create and publish your own images to the Docker Hub container library, as well as run and manage containers. And you'll also learn about advanced concepts like volumes, networks, and port mapping. You'll learn to fully Dockerize applications with a front-end, back-end, and database using React, Vue, or Svelte, as well as full-stack MERN and even our favorite Next.js. I'll teach you Docker file syntax and all the most important Docker commands and concepts like compose, init, scout, and even compose watch in a beginner-friendly way. Don't feel ashamed if you don't yet know what these are. I've been there too. By the end of the course, you'll have a proper understanding of all of these whys, hows, and whens, so you can confidently Dockerize any modern application and increase your chances of landing a job. You can think of Docker as a lunchbox for our application. In the lunchbox, we pack not just the main dish, which is our code, but also all the specific ingredients or dependencies it needs to taste just right. Now, this special lunchbox is also magical. It doesn't matter where we want to eat, at our desk, a colleague's desk, or have a little picnic. No matter the environment or different computers. Wherever we open the lunchbox, everything is set up just like it is in our kitchen. It ensures consistency, portability, and prevents us from overlooking any key ingredients, making sure our code runs smoothly in any environment without surprises. Technically, that's what Docker is. It's a platform that enables the development, packaging, and execution of applications in a unified environment. By clearly specifying our application's requirements, such as Node.js versions and necessary packages, Docker generates a self-contained box that includes its own operating system and all the components essential for running our application. This box acts like a separate computer, virtually providing the operating system, runtimes, and everything required for our application to run smoothly. But why should we bother using Docker at all? Big shots like eBay, Spotify, Washington Post, Yelp, and Uber noticed that using Docker made their apps better and faster in terms of both development and deployment. Uber, for example, said in their study that Docker helped them onboard new developers in minutes instead of weeks. So what are some of the most common things that Docker helps with? First of all, consistency across environments. Docker ensures that our app runs the same on my computer, your computer, and your boss's computer. No more "it works on my machine" drama. It also means everyone uses the same commands to run the app, no matter what computer they're using. Since downloading services like Node.js isn't the same on Linux, Windows, or macOS, developers usually have to deal with different operating systems. Docker takes care of all of that for us. This keeps everyone on the same page, reduces confusion, and boosts collaboration, making our app development and deployment faster. The second thing is isolation. Docker maintains a clear boundary between our app and its dependencies. So we'll have no more clashes between applications, much like neatly partitioned lunchbox compartments for veggies, fruits, and bread. This improves security, simplifies debugging, and makes the development process smoother. Next thing is portability. Docker lets us easily move our applications between different stages, like from development to testing or testing to production. It's like packaging your app in a lunchbox that can be moved around without any hassle. Docker containers are also lightweight and share the host's system resources, making them more efficient than any traditional virtual machines. This efficiency translates to faster application start times and reduced resource usage. It also helps with version control, as just like we track versions of our code using Git, Docker helps us track versions of our application. It's like having a rewind button for our app, so we can return to a previous version if something goes wrong. Talking about scalability, Docker makes it easy to handle more users by creating copies of our application when needed. It's like having multiple copies of a restaurant menu. When there are more customers, each menu serves one table. And finally, DevOps integration. Docker bridges the gap between development and operations, streamlining the workflow from coding to deployment. This integration ensures that the software is developed, tested, and deployed efficiently with continuous feedback and collaboration. How does Docker work? There are two most important concepts in Docker: images and containers, and the entire workflow revolves around them. Let's start with images. A Docker image is a lightweight, standalone, executable package that includes everything needed to run a piece of software, including the code, runtimes like Node.js, libraries, system tools, and even the operating system. Think of a Docker image as a recipe for our application. It not only lists the ingredients, being code and libraries, but also provides the instructions, such as runtime and system tools, to create a specific meal, meaning to run our application. And we would want to run this image somewhere, right? And that's where containers come in. A Docker container is a runnable instance of a Docker image. It represents the execution environment for a specific application, including its code, runtime, system tools, and libraries included in the Docker image. A container takes everything specified in the image and follows its instructions by executing necessary commands, downloading packages, and setting things up to run our application. Once again, imagine having a recipe for a delicious cake, the recipe being the Docker image. Now, when we actually bake the ingredients, we can serve it as a cake, right? The baked cake is like a Docker container. It's the real thing created from the recipe. Just like we can have multiple servings of the same meal from a single recipe, or multiple documents created from a single database schema, we can run multiple containers from a single image. That's what makes Docker the best. We create one image and get as many instances as we want from it in form of containers. Now, if you dive deeper into Docker, you'll also hear people talk about volumes. A Docker volume is a persistent data storage mechanism that allows data to be shared between a Docker container and the host machine, which is usually a computer or a server, or even among multiple containers. It ensures data durability and persistence even if the container is stopped or removed. Think of it as a shared folder or a storage compartment that exists outside the container. The next concept is Docker Network. It's a communication channel that enables different Docker containers to talk to each other or with the external world. It creates connectivity, allowing containers to share information and services while maintaining isolation. Think of a Docker network as a big restaurant kitchen. In a large kitchen, being the host, you have different cooking stations, or containers, each focused on a specific meal being our application. Each cooking station, or a container, is like a chef working independently on a meal. Now imagine a system of order tickets, or a Docker network, connecting all of these cooking stations together. Chefs can communicate, ask for ingredients, or share recipes seamlessly. Even though each station, or a container, has its own space and focus, the communication system, or the Docker network, enables them to collaborate efficiently. They share information without interfering with each other's cooking process. I hope it makes sense, but don't worry if it doesn't. We'll explore it together in the demo. So moving on, the Docker workflow is distributed into three parts: Docker client, Docker host, aka Docker daemon, and Docker registry, aka Docker hub. The Docker client is the user interface for interacting with Docker. It's the tool we use to give Docker commands. We issue commands to the Docker client via the command line or a graphical user interface, instructing it to build, run, or manage images or containers. Think of the Docker client as the chef giving instructions to the kitchen staff. The Docker host or Docker daemon is the background process responsible for managing containers on the host system. It listens for Docker client commands, creates and manages containers, builds images, and handles other Docker-related tasks. Imagine the Docker host as the master chef, overseeing the kitchen, carrying out instructions given by the chef or the Docker client. Finally, the Docker registry, aka Docker hub, is a centralized repository of Docker images. It hosts both public and private registries or packages. Docker is to Docker hub what Git is to GitHub in a nutshell. Docker images are stored in these registries, and when you run a container, Docker may pull the required image from the registry if it's unavailable locally. To return to our cooking analogy, think of Docker registry as a cookbook or recipe library. It's like a popular cookbook store where you can find and share different recipes, in this case, Docker images. In essence, the Docker client is the command center where we issue instructions. The Docker host then executes these instructions and manages containers, and the Docker registry serves as a centralized storage for sharing and distributing images. Using Docker is super simple. All you have to do is click the link in the description, download Docker Desktop for your own operating system, and that will help you containerize your application in the easiest way possible. It'll definitely take some time to download, but once you're there, you can accept the recommended settings and sign up. Once you're in, on the left side, you can see the links to containers, which display the containers we've made, images, which shows the images we've built, and volumes, which shows the shared volumes we have created for our containers, and other beta features like builds, dev environments, and Docker Scout. Now, return to the browser and Google Docker Hub. The first result will surely be hub.docker.com. And then open it up, go to Explore, and you can see all of the public images created so far by developers worldwide. From official images by verified publishers to sponsored open source ones covering everything from operating system images like Ubuntu, languages like Python and Golang, databases like Redis, Postgres, Mongo for MongoDB, MySQL, runtimes like Node.js, to even Hello World Docker image, and also the old peeps like WordPress and PHP. Almost everything that you need is right here. But how do we create our own Docker images? Easy peasy. Creating a Docker image starts from a special file called Dockerfile. It's a set of instructions telling Docker how to build an image for your application. There are some specific instructions and keywords we use to tell Docker what we want through the Dockerfile. Think of it as Docker syntax or language to specify exactly what we want. Here are some of the commands. From specifies the base image to use for the new image. It's like picking a starting kitchen that already has some basic tools and ingredients. Workdir sets the working directory for the following instructions. It's like deciding where in the kitchen you want to do all your cooking. Copy copies the files or directories from the build context to the image. It's like bringing in your recipe, ingredients, and any special tools into your chosen cooking spot. Run executes commands in the shell during image build. It's like doing specific steps of your recipe, such as mixing ingredients. Expose informs Docker that the container will listen on specified network ports at runtime. It's like saying, I'm going to use this specific part of the kitchen to serve the food. env sets environment variables during the build process. You can think of that as setting the kitchen environment, such as deciding whether it's a busy restaurant or a quiet home kitchen. arg defines build time variables. It's like having a note that you can change before you start cooking, like deciding if you want to use fresh or frozen ingredients. Volume creates a mount point for externally mounted volumes, essentially specifying a location inside your container where you can connect external storage. It's like leaving a designated space in your kitchen for someone to bring in extra supplies if needed. cmd provides default command to execute when the container starts. It's like specifying what dish you want to make when someone orders from your menu. Entry point specifies the default executable to be run when the container starts. It's like having a default dish on your menu that people will get unless they specifically ask for something else. And you might wonder, isn't entry point the same as cmd? Well, not really. In simple terms, both cmd and entry point are instructions in Docker for defining the default command to run when a container starts. The key difference is that cmd is more flexible and can be overridden when running the container, while entry point defines the main command that cannot be easily overridden. Think of cmd as providing a default which can be changed, and entry point as setting a fixed starting point for your container. If both are used, cmd arguments will be passed to entry point. And this are the most used keywords when creating a Docker file. I have also prepared a list of other options you can use in Docker files. You can think of it as a complete guide and a cheat sheet you can refer to when using Docker. The link is in the description. But now, let's actually use some of these commands in practice. Let's try to run one of the images listed in the Docker Hub to see how that works. Let's choose one of the operating system images as an example. Let's go for Ubuntu. On the right side of the details of the image, you'll see a command. Copy it and try executing it in your terminal. But before we paste it, first create a new empty folder on our desktop called docker_course, and then drag and drop it to our empty Visual Studio Code window. Open up your empty terminal and paste the command, docker pull Ubuntu. It's going to do it using the default tag latest, and it's going to take some time to pull it. As you can see, it's working. Docker initially checks if there are any images with that name on our machine. If not, it searches for the Docker Hub, finds the image, and automatically installs it on our machine. Now, if we go back to Docker Desktop, we'll immediately see an Ubuntu image right here under Images. To confirm that we actually installed a whole different operating system, we can run a command that executes the image. Do you know how that process is called? Creating a container. So let's run docker run -it for interactive and then Ubuntu and press enter. After you run this command, head over to Docker Desktop, and if you go to containers, you'll see a new container based off of the Ubuntu image. Coming back to our terminal, you'll see something different. If you've ever tried Ubuntu before, you'll notice that this terminal looks exactly like the Ubuntu command line. Let's test out some of the commands. ls for list. We have cd home to move to our home directory. mkdir, which is going to create a new directory called hello. We can once again ls. cd into hello to navigate to it. We can create a new hello-ubuntu.txt. We can ls to check it out if it's there. And it is. We have just used different Ubuntu commands right here within our terminal. Amazing, isn't it? We are running an entirely different operating system simply by executing a Docker image within a Docker container. For now, let's kill this terminal by pressing this trash icon and navigate back to our Docker desktop. Now, a bigger question awaits. How do we create our own Docker images? We can start from a super simple Docker app that says Hello World. Let's create a new folder called Hello hello-docker. Within it, we can create a simple hello.js file. And we can type something like console.log hello Docker. Then comes the interesting part. Next, we'll create a Docker file. Yep, it's just Docker file like this. No dots, no extensions. VS Code might prompt you to install a Docker extension, and if it does, just go ahead and install it. Now, let's figure out what goes into the Docker file. Do you remember the special Docker syntax we talked about earlier? Well, let's put it to use. First, we have to select the base image to run the app. We want to run a JavaScript file, so we can use the Node runtime from the Docker Hub. We'll use this one with an Alpine version. It's a lightweight version of Linux. So we can type something like from node 20-alpine. Next, we want to set the working directory to /app. This is the directory where commands will be run. And then /app is a standard convention. So we can type work there and then type /app. Next, we can write copy ... like this. This will copy everything from our current directory to the Docker image. The first dot is the current directory on our machine. And the second dot is the path to the current directory within the container. Next, we have to specify the command to run the app. In this case, cmd node hello.js will do the trick. And now that we have created our Docker file, let's move into the folder where the Docker file is located by opening up the terminal and then running cd hello-docker. Inside of here, let's type docker build-t, and T stands for the tag, which is optional, and if no tag is provided, it defaults to the latest tag. And finally, the path to the Docker file. And in this case, that's hello-docker dot, because we're right there. And press enter. It's building it, and I think it succeeded. Great. To verify that the image has been created or not, we can run a command docker images. And you can see that we have two images, Ubuntu as well as hello Docker, created 16 seconds ago. Now, if you're a more visual person, you can also visit Docker Desktop. Here, if you head to images, you can see all of the images we have created so far. Now that we have our image, let's run or containerize it to see what happens. So if we go back, we can run docker run hello-docker. There we have it, an excellent console log. If we go back to Docker Desktop and then open up that container and navigate inside of the files, you'll see a lot of different files and folders, but there is one special file here. Want to make a guess? Yes, it's app, which we created in Docker file. Moving inside it, we can see that it contains two of the same files we have in our application, Docker file and hello.js, exact replica. Also, if we want to open up our application in shell mode, similar to what we did with Ubuntu, we have to run docker run it hello-docker sh. This puts us directly within the operating system, and then you can simply run node hello.js to see the same output. We can also publish the images we have created on Docker, but before that, let's build something a bit more complex than the simple hello world, and then let's publish it to the Docker Hub. Which means that now we're diving into the real deal, Dockerizing React.js applications. Let's Dockerize our first React application. I'm going to do that by quickly spinning up a simple React project by running the command npm create vite add latest and then react-docker as the folder name. If you press enter, it's going to ask you which flavor of JavaScript you want. In this case, let's go with React. Sure, we can use TypeScript, and we can now cd into react-docker, and we won't run any npm install or npm run dev because the dependencies will be installed within our Dockerized container. So with that said, Now, if we clear it, we are within React Docker, and you can see our new React application right here. So as the last time, you already know the drill. We need to create a new file called Docker file. As you can see, it automatically gets this icon. And it's going to be quite similar to the original Docker file that we had, but this time I want to go into more depth about each of these commands so you know exactly what they do. And because of that, below this course, you can find a complete Docker file for our React Docker application. Copy it and paste it here. Once you do that, you should be able to see something that looks like this. It seems like there's a lot of stuff, but there really isn't. It's just a couple of commands, but I wanted to take my time to deeply explain all of the commands we're using right here. So let's go over all of that together. First, we need to set the base image to create the image for a React app. And we are setting it up from Node 20 Alpine. It's just a version 20 of Node. You can use any other version you want. And in these courses, I want to teach you how to think for yourself, not necessarily just replicate what I'm doing here. So if you hover over the command, you can see exactly what it does. Set the base image to use for subsequent instructions. From must be the first instruction in a Docker file. And you can see a couple of examples. You can use a from base image, or you can even add a tag or a digest. In this case, we're adding a tag of a specific version, but it's not necessary. And if you click online documentation, you can find even more instructions on exactly how you can use this command. Next, we have to play with permissions a bit. Now, I know that these couple of commands could be a bit confusing, but we're doing it to protect our new container from bad actors and users wanting to do something bad with it. So because of that, we create a new user with permissions only to run the app. The .s is used to create a system user, and .g is used to add that user to a group. This is done to avoid running the app as a root user that has access to everything. That way, any vulnerability in the app can be exploited to gain access to the host system. This is definitely not mandatory, but it's definitely a good practice to run the app as a non-root user, which is exactly what we're doing here. We're creating a system user, adding it to the user group, and then we set the user to run the app, user app, and you can see more information about right here. Set the username to use when running the image. Next, we set the working directory to /app, and then we copy the package.json and package.log.json to the working directory. This is done before copying the rest of the files to take advantage of Docker's cache. If the package.json and package.log.json files haven't changed, Docker will use the cache dependencies. So copy files or folders from source to destination in the images file system. So first you specify what you want to copy from the source, and then you provide a path where you want to paste it to. Next, sometimes the ownership of the files in the working system is changed to root, and thus the app can't access the files and throws an error, e-access permission denied. To avoid this, change the ownership of the files to the root user. So we're just changing it back from what we did above. Then we change the ownership of the app directory to the app user by running a new command, in this case chown, where we specify which user and group and directory we're changing the access to, and then we change the user back to the app user. And once again, if these commands are not 100% clear, no worries. This is just about playing with user permissions to not let bad actors play with our container. Finally, we install dependencies, copy the rest of the files to the working directory, expose the port 5173 to tell Docker that the container listens on that specified network, and then we run the app. If you want to learn about any of these commands, hover over it. You can already get a lot of info, and then go to online documentation if you need even more. With that said, that is our Docker file. Another great practice that we can do is just go right here and create another file similar to .gitignore. This time it's called .dockerignore. And here you can add node_modules just to simply exclude it from Docker, because we don't really need it in our node modules on our GitHub. We don't need it anywhere, not even in Docker. Docker is playing with our package.json and package.log.json and then rebuilds it when it needs to. Now, finally, once we have our Docker file, we are ready to build it. We can do that by opening up a new terminal, navigating to React Docker, and we can build it by running the command docker build -t for tag, which we can leave as default, react-docker, which is the name of the image, and then dot to indicate that it's in the current directory. And finally, press enter. This is going to build out the image, but we already know that an image is not too much on its own. To use the image, we have to actually run it. So let's run it by running the command docker run react-docker and press enter. As you can see, it built out all of the packages needed to run our app, and it seems to be running on localhost 5173. But if we open it up, it looks like the site isn't showing, even though we specified that expose endpoint right here, saying that we're listening on 5173. So why is it not working? Well, first, we need to understand that expose does only one job, and it's to inform Docker that the container should listen to that specific exposed port in runtime. That does make sense, but then why didn't work? Well, it's because we know on which port the Docker container will listen to. Docker knows it, and so does the container, but someone is missing that information. Any guesses? Well, it's the host, is the main computer we're using to run it. As we know, containers run in isolated environments, and by default, they don't expose their ports to the host machine or anyone else. This means that even if a process inside the container is listening on a specific port, the port is not accessible from outside the container. And to make our host machine aware of that, we have to utilize a concept known as port mapping. It's a concept in Docker that allows us to map ports between the Docker container and the host machine. It's exactly what we want to do. So to do that, let's kill our entire terminal by pressing this trash icon, reopen it, re-navigate to react-docker, and let's run the same command, docker run, and then we're going to add a p flag right here and say map 5173 in our container to 5173 on our host machine, and then specify which image do we want to run, and press enter. Now, as you can see, it seems to be good, but if I run it, same things happens again. It's not Docker's fault, but it's something that we missed. It's Vite. If you read the logs right here, it's going to say use -- host to expose. So we have to expose that port for Vite too. So let's modify our package.json by going right here and adding the -- host to expose our dev environment. And now again, we'll have to stop everything, kill our terminal, reopen it, re-navigate to React Docker, and then run the image again. Which makes you wonder, wouldn't it be great if Docker does it on its own whenever we make some file changes? And the answer is yes, definitely. And Docker heard us. Later in the course, I'll teach you how to use the latest Docker features that allow us to automatically build images and save us from all of this hassle. But I first want to teach you how to do it manually to understand how cool Docker Compose is, which I'm going to teach you later on. So let's just rerun the same command. And now we get an error. This means that something is already connected to that port. And this indeed is true if you check out our containers or images. We have accumulated a large number of images. So let's do a quick practice on how to clear out all of our images or containers. Back in our terminal, we can run a command docker ps, which is going to give us a list of all of the current containers alongside their IDs, images, created status, and more, as well as on which ports are they listening on. This is for all the active running containers. And if we want to get absolutely all containers, we can run docker ps-a. And here you can see absolutely all containers that we have. That's a lot. Now the question is, how do we stop a specific container? Well, we can stop it by running docker stop and then use the name or the ID of a specific container. You can use the first 3 digits of the container ID, or you can use the entire name. So let's use C3D. C3D, and if you get back the same command, it means that it successfully stopped it. If we go back to containers, you can see that the C3D is no longer running. But now let's say we have accumulated a large number of containers, which we indeed have, both the images and containers. So how can we get rid of all of the inactive containers we have created so far? Well, we can do that by running docker container prune. If you run that, it's going to say this will remove all stopped containers. So let's press Y, and that's fine. We only had one that was stopped that we manually stopped, and it pruned it. But you can also use the command docker rm to remove a specific container by name or its ID. So let's try with this one, AA7. Docker rm AA7 and press enter. Here we get a response saying that we cannot stop a running container. Of course, you could always use the -- force, and that's gonna kill it. We can verify right here. These commands are great, and it's always great to know your way around the CLI. But nowadays, we also have Docker Desktop, which allows us to play with it within a graphical user interface, which makes things so much simpler. You can simply use the stop action to stop the container, or you can use the delete action to delete a container. It is that easy. Similarly, you can do that for images by selecting it and deleting all images. And you can follow my process of deleting everything right now. I just want to ensure that we have a clean working environment before we build out our React example one more time. And while we're here, if you have any volumes, feel free to delete those as well. There we go. So moving back, we want to first build out our image. And now let's repeat how to do that. You simply have to run docker build -t, the name of the image, and then dot. This is going to build out the image. After you do that, we have to run it with port mapping included. So that's going to be docker run -p, map the ports, and then the name of the container you want to run. And press enter. It's going to run it, and you can see a bit of a difference right now here. It's exposed to the network, and if you try to run localhost 5173, you can see that this time it actually works. That's great. But now, if we go back to our code, go to source, app, and change this Vite and React to something like Docker is awesome, and save it, back on our localhost, you can see that it didn't make any changes. That's very unfortunate. We hope that this container could somehow stay up to date with what we are developing. Otherwise, it would be such a pain to constantly rebuild containers with new changes. This happens because when we build the Docker image and run the container, the code is then copied into that container. You can see all the files right here, and they're not gonna change. So even if you go right here to app and then source and then app tsx, right click it and click edit file, you'll be able to see that here it still says Vite plus React. So what can we do? Well, we'll have to further adjust our command. So let's simply stop our active container so we can then rerun a new one on the same port. Let's go back to our Visual Studio Code, clear it, make sure that you're in the react-docker folder, and we need to run the same command. Then we have to also add a string sign, $, pwd, close it, and then say :/app and close it like so. It seems a bit complicated, doesn't it? What this means is that we tell Docker to mount the current working directory where we run the docker run command into the app directory inside the container. This effectively means that our local code is linked to the container, and any changes we make locally will be immediately reflected inside the running container. This tiny pwd represents the current working directory over here. It executes in the runtime to provide the current working directory path. And V stands for volume. That's because we're creating a volume that's going to keep track of all of those changes. Remember that we talked about volumes before? They try to ensure that we always have our data stored somewhere. But before you go ahead and press enter, there's one more additional flag that we have to add to this command. And that is yet another -v, but this time /app/node_modules. Why are we doing this? Well, we have to create a new volume for the node modules directory within the container. We do this to ensure that the volume mount is available in its container. So now, when we run the container, it will use the existing node modules from the named volume, and any changes to the dependencies won't require a reinstall when starting the container. This is particularly useful in development scenarios where you frequently start and stop containers during code changes. So let's run it. It's running on localhost 5173. Docker is indeed awesome, but now the question is, if we change it, what's going to happen? So we go here and say something like Docker is awesome, but also add a couple of whales at the end, press save, and then you can see pm vt update source app tsx. And now if we run it, we have a couple of whales right here. There we go. So whenever you change something, you'll see the result instantly in the UI. That's amazing. And even if we go back to our Docker desktop, you can see that now we have a volume that keeps track of these changes. And if you go under containers, go to our active container, go to files, and then let's go to app, source, app tsx, and edit, you can see that the changes are also reflected right here. So that's it. You have successfully learned how to Dockerize a front-end application. Not many developers can do that, but you are just getting started. Now that we have created our Docker image, let me teach you how to publish it. We can do that using the command line. So let's go right here, kill our current terminal, reopen it, and cd into React Docker. Next, we can run docker login. And if you already logged in with Docker Desktop, it should automatically authenticate you. Next, we can publish our image using this command, docker tag react-docker. Then you need to add your username and the name of the image. You can find your username by going to Docker Desktop, clicking on the icon on top right, and then copying it from there. In my case, it's JavaScript Mastery, and then I'm gonna do /react-docker. It's okay if we don't provide any tag right here, as the default tag is going to be :latest. Also, don't forget that below this course, I provided a complete list of all of the commands, including different tag commands, to help you get started with Docker anytime, anywhere. So check them out and try running some of them. Finally, let's publish our image. And now we have to run docker push JavaScript Mastery, or in this case, your username, /react-docker. And this is going to actually push it to our Docker Hub. There we go. Now, if you go back to Docker Desktop, you can see that we have a JavaScript Mastery React Docker image that is now actually pushed on the hub. And you can also check it out right here by going to local hub images, and then you can see JavaScript Mastery has one latest image. And another cool thing you can do is go to hub.docker.com, where you can find your image published under repositories, and then check out your account right here, and you'll be able to see your React Docker image right here live on Docker Hub. And now other people can run this image as well and containerize their applications by using it. How cool is that? And that's all it is to it. You have successfully published your first Docker image. But now that you know the basis, let's find a more efficient way of Dockerizing our applications. Oh yeah, developers are lazy. So writing and running all of these commands for building images and containers and then mapping them to host is just too much to do. But it's not the only way. We can improve or automate this process with Docker Compose and run everything our application needs to run through Docker using one small single command. Yes, we can use a single straightforward command to run the entire application. So say hi to Docker Compose. It's a tool that allows us to define and manage multi-container Docker applications. It uses a YAML file to configure the services, networks, and volumes for your application, enabling us to run and scale the entire application with a single command. We don't have to run 10 commands separately to run 10 containers for one application, thanks to Docker Compose. We can list all the information needed to run these 10 containers or more in a single file and then run only one command that automatically triggers running the rest of the containers. In simple words, Docker Compose is like a chef's recipe for preparing multiple meals in a single dinner. It allows us to define and manage the entire cooking process for recipes in one go, specifying ingredients, cooking instructions, and how different parts of the meal should interact. With Docker Compose, we can serve up our entire culinary experience with just one command. And while we can manually create these files on our own and set things up, Docker also provides us with a CLI that generates these files for us. It's called Docker Init. Using Docker Init, we initialize our application with all the files needed to Dockerize it by specifying our tech choices. So let's go ahead and create another Vite project, which we can use to test out the features of Docker Compose and Docker Init. We can open up a terminal and then run npm create vite add latest. In this case, we can call it vite-project and press enter. It's going to ask us a couple of questions. It can be a React TypeScript application. We can cd into it. And please make sure that you are in the Docker course, meaning in the root of our folder. So it needs to create it right next to React. If you were in React before when you run this command, it's going to create it inside of it. If that's the case, delete it and just navigate to Docker course and then run the command. Now we can cd into Vite project and we can learn how to use Docker Init. It's so simple. You simply run Docker Init. That's all there is to it. And it's going to ask you many questions based off which it's going to generate a perfect YAML file for you. So what application platform are we planning on using? In this case, it's going to be Node, so you can simply press enter. What version? You can just press enter one more time to verify what they're saying in parentheses. 20 is fine with us. npm is good. Do we want to use npm run build? No, actually. In this case, we're going to say no, and we're going to say npm run dev. That's what we want to use. And the server is going to be 5173, and that's it. We can see that this has generated 3 new files for us. The Docker file, which we already know a lot about, this one has some specific details in it, but you can see that again, it's based off of the same thing. It starts from a specific version, sets up the environment variables, sets up the working directory, and runs some commands. We also have a Docker ignore, where we can ignore some additional files. And then there's this new file, compose.yaml. While all of these files are important, with using Docker Compose, YAML is the most important one. And you can read all of these comments, but for now, I just want to delete them to show you what it is comprised of. We simply define which services we want our apps or containers to use. We have a server app where we build the context, specify environment variables, and specify the ports. Of course, these can get much more complicated in case you have multiple services you want to run, which is exactly what I want to teach you right now. Here, they were even kind enough to provide an example of how you would do that with running a complete Postgres database. So you can specify the database image, and additional commands you can run. But more on that later. We're going to approach it from scratch. For now, we can leave this empty compose YAML. And first, let's focus on just the regular Docker file. In this case, we can replace this Docker file with the one we have in our React Docker application. So copy this one right here and paste it into this new one. This one, we already know what it is doing. Now, moving inside of the YAML file, here we can rename the server into web. as that's a common practice for running web applications and not servers. We can also remove environment variables as we're not using any. And we can leave the port. Finally, we need to add the volumes for our web service. So we can say volumes. Make sure to provide a space here and then a dash. And that's going to be .:/app and another dash /app/node modules. Does this ring a bell? It's similar what we have done before manually by using the docker build command, but now we're doing it all with this compose YAML file. And now all we have to do is run a new command, docker compose up, and press enter. And as you can see, we get a permission denied. You never want to see this. If you're in Windows, maybe you're used to seeing this every day, in which case you simply have to close Visual Studio Code, right-click it, and then press Run as Administrator. That should give you all the necessary permissions. On macOS or Linux, you can simply add sudo before the command. Then it's going to ask you for your password, and it's going to rerun it with admin privileges. So let's press enter. And the process started. It's building it out. Now let's debug this further. We get the same response we've gotten before. What could this be? Port is already allocated. Oh yeah, we forgot to delete or close our container that we used for previous React application. So now we know the easy way to do it. We simply go here, we select it, and we can stop it or delete it. Once it is stopped, we can go back and then simply rerun the command. I want to lead you through all of the commands together, even with the failed ones, just so you can get the feel of how you would debug or reapproach specific aspects once you encounter errors. That's what being a real developer is: getting stuck, resolving the obstacle, and getting things done. And finally, let's run the command. It's running it, and if we go to localhost 5173, the same thing as before. Any guesses? The answer is that we once again forgot to add the -- host to our vite dev script right here. So if we added, stop our application from running by pressing Ctrl+C, this is going to gracefully stop it. The cool thing about Docker Compose is that it's also stopping the container that it spun up. And now that we have canceled our action, we can try to rerun it with sudo docker compose up, but this time with host included, and press enter. It's going to rebuild it, and if we open it up, now it works. But still, this isn't optimal for developer experience, is it? Every time we make a change to the package file, we have to rerun the container. Sure, Docker Compose solves the problem of showing up-to-date code changes through volumes, letting us manage multiple containers in a single file, and lets us do both things, building and running images. But it still doesn't do it automatically when we change something related to the package files or when we think it's needed to rebuild the image. And this is where our next Docker feature comes in: Docker Compose Watch. As its name suggests, Docker Compose Watch listens to our changes and does something, like rebuilding our app, rerunning the container, and more. It's a new feature that automatically updates our service containers when you work. So what specific things can we do? With Docker Compose Watch, we can do three main things. First of all, we can sync. The sync operation moves changed files from our computer to the right places in the container, making sure that everything stays up to date in real time. This is handy when we're working on any app because it lets us instantly see any changes we make while the app is running. The second thing Docker Compose Watch can do is rebuild. The rebuild process starts with the creation of new container images, and then it updates the services. This is beneficial when rolling out changes to applications in production, guaranteeing the most recent version of the code is in operation. And finally, it can perform something known as a sync restart. The sync restart operation merges the sync and rebuild processes. It begins by syncing modifications from the host file system to the container paths and then restarting the container. This is beneficial during the development and testing of applications, ensuring that the most recent code version is active with immediate reflection of changes in the running application. And in simple terms, Docker Compose File Watch is a cool tool that keeps our cooking ingredients up to date while we're in the kitchen. To make sure it works properly, we need to tell it how to build each meal. Of course, by defining the build section in our Compose YAML file. This way, when we tweak a recipe or make changes to our application, Docker Compose File Watch knows how to update the meal, or in this case, the service container. To see it in action, I have created a basic MERN project. So first, download the starter code from below this course, then rename it from starter to just MERN Docker. And you can see that this is your typical full stack application. It has the front end, which is a React application, and a backend, including a database. Now I'm gonna teach you how to Dockerize it. As you can see, we're Dockerizing everything from vanilla files over to React, Vite, MERN, and later on, even Next.js. I want to fulfill the promise of this video, and that is to teach you how to Dockerize any application. So let's start creating our first Docker files. You know the drill, don't you? I will begin by creating a new Docker file for the frontend repository. And here, we can essentially paste everything we already had within the React project, because this is not going to change much. So let's copy it and paste it right here. Now, just to make sure that this is a bit clearer and simpler to understand, we can also remove the comments, as now we know what most of these commands do. So let's remove all of the comments, and then we're going to have a much cleaner working environment. There we go. And in this case, as you already know, doing this add group, add user, it's just an extra step to make to add more safety to our container, but it's not necessary. So in this case, we can even comment out these two commands as well as these three commands. So that leaves us with something like this: get the from image, set the working directory, copy it, run it, copy the entire app that got installed after running npm install, expose it, and run it. This is a simple Docker file for our React application, and now we have it within our frontend directory. Don't forget that we can also add a .dockerignore, which is going to just ignore node_modules. And this entire Docker file, we also have to have it for the backend because it's going to be another container. So here we can create a new file called Docker file and paste everything we have here. We can modify it slightly though, because this time we want to expose it on a different endpoint, such as 8000, and we also are going to run it by running npm start, not npm run dev. That's it. We can also add a .dockerignore and add the node modules because we want to ignore them on the backend side as well. So now we have everything we need besides one thing that ties those two services together. And that, my friends, is the compose.yaml file. This allows us to specify everything we want to do with this specific Docker Compose application. And I really took my time to comment this one file in its entirety so you can know exactly what each line does. So below this course, you can find a complete Compose YAML file for the MERN application. Copy it and paste it here. It's about 100 lines long, but it only has about 10 to 15 runnable lines. Everything else is just comments. But I wanted to go over the comments with you so we can fully understand how to create a bit of a more complicated YAML file that runs 3 different services: web, which is our front-end application, API, which is our backend, and the database at the same time. So let's dive deeper into this together. First, we have to specify the version of Docker Compose. This is not a version of Docker. This is just a version of the Docker Compose file we're using. In this case, 3.8 is fine, or if you're using some newer Compose features, then you want to bump it up according to the documentation. Next and most important step is to define the services and containers to be run. You do that by saying services, and then you define individual services. In this case, we're defining the frontend service. You can use any name, but a standard naming convention is to use web for the frontend. So as we move to this file, I'm going to remove the comments to show you that indeed it is much simpler than it looks like with all of those comments. We're going to dive deep into web soon, but for now I have collapsed it for you to see the general structure. Then we define the API or the service container, and then we define the DB service. Finally, we define the volumes to be used by the services, and here we create a new volume of a name anime, as this app is going to be about showing anime shows. So looking at this from a high-level overview, we have the version, we have the services, and we have the volumes. So now let's dive deeper into each one of the services, starting with web. First, we need to use the depends on command to specify that service depends on another service. In this case, we specify that the web depends on the API service. This means that the API service will be started before the web service. Okay, that's important because to be able to use our front-end application, we need to be able to have the API loaded. Then we specify the build context for the web service. What this means is simply, hey, tell me where the Docker file for this service is located. In this case, it is in /frontend. Then we specify which ports to expose. The first number is the port on the host machine, and the second one is the port inside the container, and we use a concept known as port mapping. Then you can specify any environment variables. This is pretty simple. We simply expose the Vite API URL to localhost 8000. And then everything below is for the Docker Compose watch mode. Anything mentioned under develop will be watched for changes by Docker Compose watch, and it will perform the action that's mentioned here. So we say develop, and then we specify the files to watch for changes. We watch for path frontend package.json, and then rebuild the container if there are any changes. Similarly, we watch for package log.json, and then perform the action of rebuild whenever something changes. We also want to listen for the changes in the frontend directory, and then we simply call the sync action with this one. And this is it for the web service. Diving into the API, it's similar. We define that the API service depends on the database service. We specify the build context for the API service. We specify the ports to expose and do port mapping. We specify the environment variables, in this case the DB URL. And finally, we establish the Docker Compose watch mode for the API service by specifying the files to watch for changes. Same thing as before in the package.json and package log.json, and then watches for changes and then syncs it across the entire application. And finally, we have the database. Here, we want to specify the image we want to use for the DB service from the Docker Hub. If we have a custom image, we can specify that in this format. In the above two services, we're using the build context to build the image for the service from the Docker file. So we specify the build as /frontend or build is /backend. This is interesting. So we're not referring to existing images, rather we build our own images from Docker file as we learned before. But in this case, we are using image from the Docker Hub, so we specify it as image mongo add latest. You can find the name and the tag, and of course all of this is available on the Docker Hub. You can just explore the official images. So we use it, we specify the ports and do port mapping. And generally, you want to put the ports to your MongoDB Atlas here. But for demo purposes, we can use a local MongoDB instance. And usually, MongoDB runs on port 27017. So we're exposing that port and mapping it to the port inside the container. How would you test this out locally to see if the database is live? Well, you can use a tool called MongoDB Compass. Finally, we specify the volumes to mount for the DB service. In this case, we want to mount the volume named anime inside the container at a data.db directory. This is done so that the data inside of the MongoDB container is persisted even if the container is stopped. And this is it. This is how you create your first YAML compose file. It's not that hard, is it? It's not that easy either. This is your first time, but trust me, you will get better. But this is a YAML file for already a pretty big application with 3 separate services. You can try building your own that is much simpler. And as a matter of fact, we have already done that in the last project where we have a really simple, just a web service in here. So now we have stepped up our game a bit and we're doing it for a complicated app to show you the beauty of Docker Compose file watch. So remember, we're building 3 different images and containers through one file and one command. That's power of Docker Compose. And on top of that, we're using Docker Compose file watch to automatically build and run these containers if we make any changes to the application. So let's open up our terminal, cd into MERN-docker, and run sudo docker compose up and press enter. Enter your password and see the magic happen. It's going to run all the services one by one. Notice that first it created our DB image and container. Then it's going to start working on the API, and we can see that here. And finally, it's going to move over to our web application exactly as we have specified in our YAML file. So let's leave it do its thing. There we go. After about a minute, we can see that the process has finished by this long log file right here. Don't worry, it's not an error. Rather, you can see that it successfully containerized all 3 different applications, the DB, the API, and the web, and attached them together. If we go back to Docker Desktop, we can see that right here. If we go to Docker Desktop, we can see that right here. We have the MERN Docker Web, MERN Docker API, and Mongo. We also have 3 different containers under MERN Doc right here, DB, API, and web. And we also have the specified volumes. So now that we have this running, let's open up our browser and navigate to localhost 5173. There we go. We have a fully functional MERN application running on your device locally without you having to spin up the database, the front end, and the back end, and inputting all of these environment variables manually. It just works. That's the power of Docker. What we have here is a simple application where you can share your favorite anime. So go to share, enter the name. I'm gonna do something like My Hero Academia. You can also enter the link, and you can also enter a description. Finally, click submit. That's it. If you refresh, you can notice that it stays there, and this entry actually got added to our database. Before Docker, we would have to have 2 or 3 terminals open, running front-end, back-end, and database at the same time. Now, it's just one command, and we have our app running in real time. But now, let's try to make some changes. If I go right here and navigate to our front-end part of our application, as that's the easiest to notice, we can go to app.jsx, and right in our navbar, let's try to add a new link by duplicating this one and say something like popular. If we save it and go back and reload, nothing changes. So how can we ensure that the updates happen automatically and in real time? Back in our code, we can open up a terminal and then split it to create a new one alongside it. There, we can run the command sudo docker compose watch. We're finally getting to the watch part. If you press enter and enter your password, you'll see that something will start to happening. It looks like it's starting with the watch configuration. So now, if I save this file right here with popular included, go back to the browser and reload, indeed popular is there. And you can see that if I save the file, something happens here. There's an update happening in real time. So if I change it, save it, and go back, it's updated in real time. Now, let's remove it. And let's try to test whether this works for the backend as well. We can do a quick test by installing a simple package called colors.js. That's just npm i colors. and it allows you to change the colors in your terminal. With this, we'll very easily be able to see whether the package got installed or not. So back in our code, we can navigate to our package.json of the backend part, and using our terminal, we can install the package. So let's split the terminal one more time, cd into backend, and then let's run npm install or npm I colors. This is going to add it. We can kill this terminal in the middle, and immediately you can see that something started happening on that watch part. It looks like it's listening to it and rebuilding the entire application with this project installed. That's great. Let's also explore the code a bit. Right here in the index, you can see that we are enabling this colors package coming from colors, and we are also logging it out in a rainbow of color whenever we go to localhost 8000. So back in our browser, let's simply re-navigate to localhost 8000. We get a hello world here, but we're more interested in this hello world here, because this one means that the package got successfully installed. There we have it. Without a refresh, rebuild, or rerun, our application works in real time with the help of Docker Compose Watch. Now, before we move on to the very interesting part of this course, which is Dockerizing full-stack modern Next.js applications, let me show you another cool Docker's new and cool feature. When we create container images for our applications, we're essentially stacking layers of existing images and software components. However, some of these layers or components might have security vulnerabilities, making our containers and their applications susceptible to attacks. Docker Scout is a tool that helps us be proactive about security. It scans our container images, looks at all the layers and software pieces, like building blocks inside them, and creates a detailed list called a software bill of materials, SBOM for short. This list includes everything our container is made of. Then, Docker Scout checks the list against an always updated database of known vulnerabilities. It's like having a continuously updated list of potential weak points. If it finds any, it lets us know so we can fix them before deploying our application. We can use Docker Scout in different places like Docker Desktop, Docker Hub, and even through commands in the Docker command line interface. If we go back to Docker Desktop, you can see the Docker Scout section right here on the left. And from the dropdown, we can decide on which image we want to analyze. Let's select the MERN Docker Web latest, as we just created it, and see what it shows. Right now, it says 0 vulnerabilities. And let's view the packages and CVEs. Here, you can get a complete report analysis of our image. Luckily, our application doesn't have any vulnerabilities. It mentions all the things that we need from all the layers and images that are related to it, and a list of packages. It's worth checking every time to ensure that we're not shipping anything that is easy to break. Now, let's address the elephant in the room, and that is how to Dockerize a Next.js application. More specifically, a full-stack Next.js application. And the short answer would be the same as what I've taught you before in this course. I went ahead and created a small full-stack application using v0.dev. This is Vercel's new component generator. And the starter source code for that application is below this course. Copy it, paste it right here, and just rename the starter for just Next Docker. So for one last time in this course, let's take this as a recap of how to Dockerize a full-stack modern Next.js application. First of all, we're going to open up our terminal and navigate to Next Docker. Then we're going to initialize the Docker part of the application by running docker init. In this case, we can select node. Version 20 is fine. We're going to use npm. We don't want to use npm run build for starting the server, but we do want to use npm run dev, as that's how it is with Next.js applications, and we want to listen on port 3000. Now, as Docker CLI conveniently tells us, 3 files have been created. the Docker files, the compose YAML, and the readme docker.md. All the files we need to Dockerize our application are ready. Now, let's take a moment to review them and tailor them to our application. Let's start with our Docker file. Here we have some comments to help us get started, but at this point, we don't really need them. So this is how you can define specific arguments to be used within your application. For example, they define node version so they can specify it in multiple places. But as a matter of fact, let's rewrite this on our own to fully brush up on our knowledge of Docker file syntax. We can start by inheriting from a specific image. In this case, we can start from node, as our application is going to be based off of node. Feel free to provide a specific version or just leave it like this. Then we want to set the working directory by saying workdir /app. We want to copy the package.json and package.log.json into the image by saying copy package everything.json into /. Then we want to run npm install. We want to copy the rest of the source files into the image by saying copy ... We want to expose the 3000 endpoint. And finally, we want to run npm run dev. That's all there is to it, of creating your Docker file capable of Dockerizing Next.js. Now, let's also look into our compose YAML file. In this case, let's also rewrite it from scratch. First, we can define the version of our compose YAML file. Something like 3.8 in this case should do. And just to repeat, it's not a version of Docker we're using. It's a version of a specific YAML file syntax for Docker. So if you're using some newer syntax, just figure out in which version they're supported. Next, we define services. We can call it something like frontend for the frontend side. And then we define build, where we have the context right here, we're immediately in there, and Docker file is going to be called Docker file. So in this build, we're just pointing to the Docker file from where it's going to build out our image. Then we can define the ports right here next to the build by saying -3000 mapped to 3000. And then we want to use Docker Compose to watch for the changes and rebuild the container. We can do that by going below the ports and then saying develop, watch, and then we provide what we want to watch for. So which path? In this case, we can do -path of /package.json, and then the command or the action in this case of what we want to do once it notices the changes in that file. In this case, we want to rebuild our image. We can also repeat the procedure with path of /next.config.js, and it's going to be action rebuild. We can do that also for the package log.json. So path is something like /package-log.json and action rebuild. And finally, we can add a path for all the other files, meaning simply where we're going to do the target of app and an action of sync. So this is going to make sure that we sync our container with our host machine. Finally, we can define some environment variables right here below develop. So environment. In this specific app, I'm using MongoDB Atlas. So we need to pass in the connection string. I'm going to say DB URL. And then I'm going to give you access to this string. You can also find it below in the course. It's going to be this one right here. And don't forget, if you were running a local instance of MongoDB, you would need to do something that looks like this, where you define the image, you map the ports to the local MongoDB campus version, define the environment variables, and then specify a volume. But in this case, it's done for us automatically because we're just referring to the deployed MongoDB Atlas database. Finally, we specify the volumes of tasked because our application is going to be about tasks. And that's it. That's our compose YAML. Finally, open up the terminal and you simply need to run sudo docker compose up. enter your password, and it's gonna start building it. It's gonna start with the front end, and soon you'll see a lot of things that you see when building out your typical Next.js application. It will start installing all of the packages and everything needed to run our application locally. And there we have it. Our application is not only Dockerized, but live on localhost 3000. Let's open it up and test it out. There we go. Now we can see that this is a typical to-do application where we have some registered tasks. We can see the task right here. We have one task to learn Docker right here. And thankfully, you'll be able to tick that box off once you finish watching this video. And we can also create a new task. Now, I purposefully left this typo right here in registered to check whether we can fix it within our code. What do you think? Will it work or not? So if we go to search and search for registered, you can see it right here on top. It's actually being mentioned 2 times. So if we change it and spell it properly, which is registered, and go back to our application, it didn't work. Our Docker wasn't watching for changes. Unfortunately, we forgot to tell Docker to watch for changes. But thankfully, you know how to do so. Simply open up the terminal, split it, and run sudo docker compose watch. Enter the password. It started doing its thing, and it looks like it's listening for changes. Now, we have made the changes already, so let's simply press Command or Control S to save them. And as soon as you do that, you'll see syncing frontend after changes were detected. Going back to our application and reloading, you can see that the typo has indeed been fixed. So, there you have it. You just learned how to Dockerize the most modern web application there is, a full-stack Next.js application. But with that, you've also went through the process of Dockerizing a simple vanilla JS script to doing something like Vite, React, MERN, and then Next as well. Not only have you learned all of the most important Docker concepts, you have put them to use in 5 different kinds of applications. You've learned how to build images using the Docker file. You've learned how to use Docker Compose and create Compose YAML files. And with that Compose, run as many services as you want with a single command. You've also learned how to listen for changes in your applications. So in a nutshell, you've learned how to Dockerize any application you can build. And finally, let's discuss the elephant in the room. Should you or should you not Dockerize your specific application? In my opinion, it's worth considering Dockerization for any application, be it front-end, back-end, or full stack. Let me tell you why. If you have big and complex apps, they usually have many moving parts, like databases, servers, and APIs. Docker packages everything an app needs into a standardized unit or a container, making it easier to manage. Imagine having a large e-commerce platform with a web server, a database, and multiple APIs for payment, order processing, and inventory management. Dockerizing each component ensures that they work together seamlessly and can be easily deployed or scaled as needed. Similarly, if you have an app built from many small pieces or microservices, which involves breaking an app into small independent features, Docker containers are perfect for isolating and managing these services separately. For example, if you're building a social media application, you may have separate microservices for user authentication, posting content, handling notifications, and managing connections. Dockerizing each microservice allows independent development, testing, and scaling of these services without affecting the entire application. Another reason to Dockerize any app is that it just works everywhere. Our development team at JSM uses different operating systems, Windows, macOS, and Linux. And without Docker, setting up the development environment on each machine can lead to inconsistencies. Docker ensures that every developer, regardless of their operating system, works in the same containerized environment, minimizing compatibility issues. If that's what you're looking for, similar to Uber, you can Dockerize your app and reduce the development hassle. Docker also allows for easy scaling. Using Docker makes it simple to handle more users. How? Well, imagine you're running a popular online streaming service. As more users sign up, you need to scale your video transcoding service. Docker allows you to easily replicate and deploy additional transcoding containers, ensuring smooth scaling without disrupting the entire application. And with Docker, updates happen smoothly. Imagine you manage a web application with frequent updates. Without Docker, deploying updates might require manually adjusting configurations on the server, which takes time and will most likely break your app. With Docker, you can update your app consistently without worrying about breaking dependencies, ensuring that changes go live smoothly. Docker also simplifies teamwork because it provides a consistent environment for all developers. For example, if you're working on a machine learning project, Docker ensures that every team member, regardless of their local setup, works with the same environment containing the necessary libraries, dependencies, and configurations. Everyone works in the same containerized setup, reducing compatibility issues and making collaboration that much smoother. And finally, old apps, new tricks. Even for older applications, Docker can breathe a new life. It helps in managing dependencies, isolating the application, and making it more compatible with modern systems. Imagine you're working on a big tech that is using a big, scary legacy monolithic application written in an older programming language or version. Dockerizing that application allows you to isolate the application and its dependencies, making it easier to maintain from your environment where you might be using the latest versions of runtimes or languages. Almost every company uses Dockerized applications. Whether we're dealing with a small or big application, Docker can help solve problems or stop them from happening in the first place. So no matter what kind of app you're working on, using Docker has become a smart move to make things smoother and avoid issues. And congratulations. I truly do mean it. You've just learned Docker, an in-demand engineering tool. As a thank you for making it this far, for committing to learning and becoming a better developer, I want to give you a reward. I'm holding a Docker swag giveaway where we'll give away some special merch to dedicated developers that came to the end of the course. To learn more and take part, just click the link in the description. Winners will be notified by email. And if you reach this point, you've done something that only few developers do. You can now confidently talk about Docker, its main concepts and best practices, and most importantly, you can Dockerize any modern frontend, backend, and full-stack app. I'm proud of you.